So we are talking about iterative binary search algorithm. Now let me give you a very simple example. And by the way, binary search algorithm is used in contexts where you have a very large array, and in that array you want to find out some element. Now if you want to find out some element, then you have different algorithms, but binary search algorithm makes it easier to search something. So you'll understand everything once we go in deep. So let us learn iterative binary search algorithm. So let me give you a very basic array. So I want my array. So my array is A, and inside this I have various elements. So 1, 3, 10, 13, 17, 18, 19, and let's say 20. Now from this array, let us say my target is to find the element, let's say 18. So let's say I want to find the element 18 from this array. So now to find this element, we're going to first solve this using iterative binary search algorithm. So first of all, so let me open the pen. So first of all, I will have two variables. So first of all, I'll have low. So my low will be 0, and my high will be equals to the length of this array minus 1. So if you write the indexes for the elements of this array, then this will be 1, this will be 0, 1, this will be 2, this will be 3, this will be 4, this will be 5, this will be 6, and similarly this will be 7. Now you can see that there are total 8 elements. So and we have indexes from 0 to 7. So high will be 7. So we have low and we have high. We have two variables which we need to update, which we need to keep on updating. Now let us go to step 1. So first of all, step 1. In the first step, what happens is that we want to find out the mid value of this array. So to find the mid value, what we will do is, so to find the mid value, what we'll do is we will add the low plus high minus low divided by 2. That should give me the mid value. So low, so mid is equals to low plus high is 7 minus low divided by 2, and this would give me 7 minus 0 would be 7, and if you divide 7 by 2, this would give me 3.5. But here we're doing double slash, so if you round off, that will give me the base, that would be 3, and 3 plus 0 would be 3. Now in the third index, in the A, there is 13. So from our array A, the third index is 13. Now compare our target with this. So 13 and 18. Now if we compare this, 13 is much lesser than 18. Now if 13 is less than 18, there is no point of checking these elements. So we don't need to go through these elements because 13 is already less than 18, which means we don't even need to check 13, 10, 1, 3. So now we'll update our array, and now we only need to search in this region. So now let us go to step 2. So if we need to search through this region, then we might as well update our low. So we can update our low as, we can increment it 1 from mid. So we can do 3 plus 1, and which would give me 4. So now from 4th element, I need to go right up to the 7th element. So 7th index. So now let us go to step 2. By the way, in the first step, we have already halved this array. We have already halved the size of the array, and now we are only searching in this region. So we don't need to search in every index again and again. So we have this index to work upon. Now we are currently on step 2. Now again, we do the same process. We find the mid. So mid would be low plus high minus low divided by 2, which is in our case now updated low is 4 and high is 7. We have not changed the high yet. High minus and low would be 4 and divided by 2. Now this would give me 7 minus 4 would be 3, and divide 3 by 2, which would give me 1.5. So the base would be 1, and 1 plus 4 would be 5. So now in our array, the fifth index, the element in the fifth index is 18. Now compare this with our target. So 18 and the target, and looks like we've already matched our target. So 18 is equals to 18. So what this will do is this will return the index 5. So this will return the index 5, and in the index 5 our target is present. So this is how the first iterative binary search algorithm works. So what we're doing is in each step we're exactly halving the size of the array. So we don't have to go through each element again and again. So what would happen if we don't get the target? So if we have kept on halving every time, and if we don't get the element, then we only do this. So we only do the steps until our left is less or equals to right. So if at some point our low becomes, let's say, 2, and our high becomes, let's say, 2, then what would happen is that there would only be one element left in this array. And if one element is left in the array, we cannot further split this array. So this would mean that there was no target in the element in this array basically. So I hope you understood this. Now let me give you a different point of view. Let me explain you this in another way. So let me go down, and so okay, I am going to make a table here. So let us see in how many let me make a table, then you will understand. So I will make a table here. So in here I would do iterations. So iterations. So here would be iterations, and here I would represent the size. So now in first iteration, the size of the array would be n, and in the first iteration you would halve the size of the array, so it would be n divided by 2. In the second iteration, this would be further split, so it would be n divided by 4. In the third iteration, it would be n divided by 8. And similarly, when you go from third iteration up to the kth iteration, this would be n divided by 2 power k. So 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, and similarly 2 power k is 2 to the power k. So in kth iteration, the size of your array would be n by 2 power k, and we would continue iterating until there is one element left in the array. So the condition to stop iterating would be when n by 2 power k would be less or equals to 1. Now if you solve this, and we can now multiply 2 power k on both sides, so this would be n less than equals to 2 power k. And if we further take log base 2, then it would be log base 2 of n, and here it would be k less or equals to k, and this would approximately be equals to log 2 of n, and this means big O of log n. So this is the complexity. So now next time, if you know the size of the array, then you can at the beginning you can guess how many iterations it would take to get certain element from that array. So before, in this case, the size of our array was 8. So if the size of array is 8, then if we put this if we put the value in this formula, then the iterations would be log base 2 size 8. So this would be how much to the power of 2 would be 8 is 3. So it would take 3 iterations to get an element from an array whose size is 8. And in here we did the same. So it took 3 steps. So now I hope you understood about the first binary search algorithm, which was iterative binary search algorithm. Now let us understand lower bound iterative algorithm. But I think the better approach would be, we have already understood theory about iterative binary search algorithm. Let us first code this algorithm, and then we'll understand theory for this algorithm, and we'll continue. So let us open Visual Studio Code. Here I have my Visual Studio Code open. I have created a file called main.py, and here we will implement iterative binary search. So now I will make a function. So the name of the function will be binary search. And in this function, I'll take two things. Which one? First will be the array, and another thing will be the target. Now let us initialize low and high. So now I will represent low as left and high as right. So at the beginning, my left would be 0, and my right would be would be 1 less than the length of the array. So length of array minus 1. So I have initialized my left and right. Now I will create a while loop. So I have to continue iterating on this array until my left is less or equals to right. Because when my less is less or equals to right, I have only one element left, and I cannot further split the array. So I want to continue iterating until this case, and for mistake I have clicked Ctrl and Enter at once. So okay. Now first step, I want to find the mid. So to find the mid, I have left plus right minus left, and we divide by 2. So we found the mid, and now we have to check a condition. Now if in the array the mid index would be is less than the target, which means that the target is in the right side. First of all, we can do one thing. If we can check that if the index in the middle, the mid, if this is equals to the target, then we have found the target. We can immediately return the mid. We can immediately return that index. And if this is not equals to target, then if array mid index is less than target, then this means that, okay, again, now this condition, if array mid is less than target, then this means that the target is in the right. And if target is in the right side, then we want to update our left by adding 1 to the mid. So basically this is this case. So we are adding 1 to the left, because there is no point of searching to the left, because because in this region our target will not be present. We are sure of that. Now another condition would be that now there would only be one condition left, which is the target is less than the array of mid, and if that is the case, then we want to subtract 1 from the mid. And we'll keep on doing this. We'll keep on halving the size of the array. And if we don't find the element until this case, then this means that the element is not present in the array. Then we can basically return -1. So when we are iterating through this algorithm, at one point this should match, and this should return me the index of the array. So let us use this. Let us see if this works or not. So I'm going to define my array. So my array is going to be 2, 4, 6, 8, 10, 12, and 14. And by the way, your array should always be sorted, because if it's not sorted, then we cannot apply this. Because if it's not sorted, we cannot be sure that the element in this would not be the target, right? So I have created my array, and let's say my target here is to find from this array the element 10. Now I print, and I will pass the array, and then I'll pass the target to this function. Now let us open our terminal. Now let us run this main.py. So Python 3 main.py, and we can see that it returned me index 4. So let us check this. So 0, 1, 2, 3, 4. Okay, this is our target. So this is working fine. I hope you understood about iterative binary search.